Welcome to this video. In here we're going to talk about linearizing data. Take a look at this example. The data in the table show the growth of texting in the US over the years. Let's let X be the number of years since 2000. So we're given a table right here. And we want to somehow establish a relationship between X and Y. So if we just, by setting the linear regression line, setting y equals mx plus b, we will get this value. And how do I get this equation? Well, I simply first, by looking at the slope, which is using every y values minus the previous one divided by their difference. And since the difference is only 1 for 2002 and 2001, so it really didn't make a difference. And you can see that the slopes are varying year by year a little bit. So what I did is I took the slope from each year with their subsequent year, adding them up and divided by total. So I get the average slope, which is 7.138. Negative 19.699 is, I actually typed all of this data into my calculator, and I got a y-intercept as this. So if you want to do it on your calculator, that will definitely be much faster. But I'm just showing you the way that you want to do it by your hand for calculating the slope. So after we enter all of those data into our calculator and graph the function and trying to get a residual plot, we got a graph like this. So we really want to ask ourselves, does this model work? Because from our previous lessons, we know that for a residual plot to be satisfy our rules, it should be completely randomness. It should not have any fan shape or any patterns. And this clearly shows the opposite way. It has a pattern. And we got a r squared equal to 71.4%. So this residual plot definitely does not work because r squared is okay, but residual plot shows a pattern, so model does not work. How are we going to do this problem then? Well, we're going to have two ways to do this. One is exponential and one is power. So I'll show you, excuse me, how to do those two ways separately. First of all, doing exponential, y hat equal to a times b to the x power. This is the formula we're going to use. First of all, test for exponential. Look at ratios. We already have the linear function. What we're going to do is, first, okay, so basically, we are not using y value anymore. We're using log y, or natural log of y. So when you enter the data on your table, you're going to use log y, or whatever your list number is, or natural log of y. So then we will set up the equation like this. And this is how we got also from our calculator. And what we're going to do is, because we want to get rid of a natural log, right, or whatever log you're using, we want to leave it just y hat. So we're going to raise both sides to the e⁻ power, and we will get rid of this natural log, and y hat is equal to e to everything right here. And by some math rules, we can separate the numerator apart with this, and we can arrange them a little bit. We can also, like, after we're separating the numerator first, we're going to separate the numerator again. But this time, we're only going to do x with this numerical number. So then, because e is a number, right, so we can actually got the value. This is the value we got, which is 1.645. It's the same as this value right here. So this is our function. And we can see that the function is actually the format as here above. So, which means that we're doing in the right way. So that's how I got the residual plot I got from this function. You can see now the plots are completely random, and they both have roughly the same numbers of plots, both above and below x-axis. And r squared is 99.996, which is pretty good. R squared is very high. The residual plot has equal number of positive and negative residuals. There's no fan shape and no pattern. Therefore, the model works. And let's take a look at the power way to do this. So the power function is y hat equal to a times x to the b⁻ power. This time, instead of doing x versus log y or natural log of y, we're using log x versus log y or natural log of x versus natural log of y. Same thing, we're gonna use the data of these two and get our equation from our calculator. And then we're gonna raise both sides to the 10th power, because this time we used log y instead of natural log of y. If we use natural log of y, then we're gonna raise everything to the eth power. Y hat is equal to 10 to the function right here, and same thing as the math way that we did above, we're gonna separate both things apart, and we're actually gonna use some log rules. So we're gonna put the 10 like the base to the exponent place to the x value. Therefore, we can cancel out the log and 10. Yeah. Oh, I'm sorry. Like, I said it wrong. Actually, we're gonna like putting this number 1.8646 into the exponent of x. Therefore, we can cancel 10 and log. Sorry. So then we will leave the answer as this function. And 10 to the negative 0.3772, we can actually get the value from our calculator as 0.4196 times x to this value. Therefore, this is our final equation for using power way. And we're using the this function, or like the data of log x and log y to get a residual plot. We can see it also has a clear pattern. It's not completely randomized as we're using exponential way. But we get our R square of 88.5%, which is good enough. But the residual plot does have a pattern, so that really preventing us to get the real answer. So even though R squared is high at 88.5%, the residual plot has a pattern. Therefore, this is not the best model. And you know what? What I'm going to tell you now is most of the cases, the original function, like getting the linear equation, exponential equation, and power equation, you're only going to choose one that fit best with your data. So in this case, we're getting a model that works best using exponential way. Therefore, that's the only way that, okay, sorry for that. So sorry, like this is really hard to monetizing. So, okay, so keep going, like, let me finish. What I want to say is, okay, so most of the cases you're only going to use one of the three ways we introduced right here. So if you already used the exponential way and you got a pretty good model, then on the test you don't have to test again for power method. You're just wasting your time basically, because the question will most likely be giving you a question that only works for one of the method that you choose. So yeah, so it's just a little tip for you to save your time. Okay, so also there's a quadratic way. I mean, this is pretty rare. I mean, maybe FRQs won't testing you on that. It can get off calculator. So I won't go deeper into it, but I'm just telling you it will also be a way that you're using a quadratic equation. But it's not a common case. So just remember exponential and power. That will give you a pretty good picture of how you're doing. How are you going to do with the data when you cannot get a great residual plot using a linear equation. Okay, I hope you learned something from this video. Thank you so much for watching.